Today we are going to learn about something about quantum theory and waves. Actually, this is a completely physical chemistry course. And those who are not theoretical chemists, especially physical chemistry, has many branches. Among them, very few are working on quantum chemistry, and this is called completely theoretical chemistry. So we have some imaginary equations. We always say how many electrons are outside in the cell, or how many electrons in different orbits. Actually, electron is not a dot particle or anything. If we consider an atom, we have certain area outside the nucleus where the availability of electrons is more, and that is explained or defined as a function. That means where the possibility of having electrons is high, we represent by using some equation, and using or solving that equation we can get the orbital picture or where the electrons can reside. We represent by like that way. If we have some atoms, then we can have the molecule, and we can guess the properties of different molecules from this. So that is quite, I don't want to say that word, but this topic is a little bit tough. I would say maybe toughest in this course. So don't be afraid. I'll try to make as much easy as possible and try to avoid the unnecessary things. Okay. So first, electromagnetic radiation. Electromagnetic radiation everywhere we have. This is our light. I'm using this pointer. This is also a kind of electromagnetic radiation, and that can be represented by a like this structure. So it has some nature that it is repeating same property or similar way at different time. So electromagnetic radiation, what we say, form of energy transmission through space or medium. To transmit energy, you always don't need to have any medium. Sometimes you can transfer some sound wave. In that case, you may need to have some medium. Sound also a kind of wave, and it transmits by compressing. If you have some medium, air medium, let us consider air medium. So what happens if you produce a sound here? In that case, this sound first strike this wall, or this is a medium, and then when it strikes this wall or this medium, it hit towards from the source. Then some of it moves little bit here, and then this wave again strike this. Similarly, one by another after. By this way, sound is moving. But to move the electromagnetic wave, we don't need to have any medium. So that we know the sun is very far away from us. Still, we are getting the light. And you are familiar with that. There are space. That means we do not have anything in between sun and Just if we consider this is our Earth and maybe here is our Sun, and we have something in between here, maybe up to this level. That means from the surface to this level, it can be around 100 kilometers like this. So up to 100 kilometers, we have something like as moisture, oxygen, nitrogen, carbon dioxide, and many other things, or dust particles, different things. But if you go beyond this, then we have nothing. Still, we are getting light from the sun, and even sometimes if it has any medium, it do not heat up. If you consider that, when do you know what is the height when you are going by airplane? What is the average height from the surface? Huh? Guess? Huh? 10,000 feet. 10,000 feet. 10,000. 10,000 feet. What is the height of Everest? Mount Everest? 8848 meter. Then, if you consider 8848 meter, that means if you are considering this is around 9,000 meters, is it? Around. Just we are considering the standard number 8848 9,000 meter. Then 1 feet equal how many meters? Or other way, 1 meter equal how many feet? More than 3 feet. Just if you consider calculate by inch, 37.39 inch. I cannot remember exactly. 37.39 inch equal 1 meter equal more than 3 feet. 3 plus feet. That means if you consider this 10,000 feet, which corresponds to 3,000 meters or 3,300 meters. So, if you try to go using plane, using this by this height only, in that case, you can clash with the Mount Everest. But actually, the plane moves around 33,000 feet. 33,000 feet approximate, or around 10 kilometers. Okay, that means if this is around 8.8 kilometer or 8,848 meter. So when you go above Mount Everest, normally it should not clash. And just what I'm going to tell you, when we go by plane, that time the sun is giving light in the daytime. Definitely we are getting the light. However, the plane is not get heated. Therefore, I have mentioned that if the sun is giving light, still if it has any medium, it do not heat up. So, to transfer electromagnetic wave, you don't need to have any medium. So, it can transfer energy. We know the light is giving as an energy. So, the sun is giving energy. Therefore, the light is a form of energy, or electromagnetic wave is a form of energy which do not need any medium to transfer. Okay? You do not need, it can form of energy transmission through space or vacuum. That means, vacuum, this is another very good term. I have used a very high vacuum. system. That means for any experiment, I have worked with the molecule, very small particle. What we consider, just if you consider only H2O, this is one molecule. In terms of radius, this is very small, we cannot see. In terms of, it can be around picometer. Picometer, you know, what is the value? Around 10 to the power minus, that is nano. 12 minus 12 meter, that is the picometer. So picometer is 10 to the power minus 12, so that is very small number. Even in the first class I have mentioned about the face wash, is it? Just we are using carbon or charcoal nanotube to make the face wash, or inside the face wash, even smaller than this. So water molecule, that is very small. So if you want to study any molecule like this, you need to have a system that nothing is there, no water, no air, or any other contaminant. So we had a very large chamber made of stainless steel, and we had several very high powerful pumps, so that we could take out all the air from the inside. If you put some pump in this room, just maybe you do not have any ventilator. So if you want to take some air from this room, right now the door is open. This door we can also open. So we can take out some air. If you, in the kitchen, you have some exhaust fan, is it? So exhaust, what is doing this? It is collecting the hot air. It is collecting the hot air and it is giving out outside. Similarly, we are using some pump and we are collecting the inside air and give it to the environment. So by using that types of pump, we can reduce the inside contaminant or whatever the component, nitrogen gas, oxygen gas, or whatever, moisture. So if you do not have anything inside, then you can, if you apply certain amount of energy to a molecule, you can change the orientation of the molecule, kinetic energy, velocity, whatever you want. Just then, that means you have learned the experiment about the Galileo, how much time it is taking to fall a substance, free falling substance. Just if you have two different substances, one is very light and one is very heavy. So if it is coming without any obstacle, both the substances were coming at the same time. So exactly we are making certain condition. That means there will be no obstacle in the system. That means in the chamber what we are making the instrument. So we can give some light to the molecule. How much light we are giving, we can estimate what is the light or what is the energy we are giving. Based on that light, what would be the character of the molecule? We can determine. At the end, we have some detector, so we can monitor what is the change we are observing. So that means if we want to study any molecule or any system which is very low energy or very low concentration, in that case, we need to have the system free from any types of obstacles. So we are taking away all the gases. That is called as vacuum. So nothing is here. Normally, if we have the inside pressure, what is the pressure in this room? Normally, environment pressure 100 what? in any unit you can say. Yes. Okay. But if I say in number, that is 1 atmosphere. You know, 1 atmosphere. Just we are in the atmosphere, so we are considering the pressure. This pressure is 1 atmosphere. And if you change into millibar, we have different types of pressure unit. We can use Pascal, kilopascal, and then PSI, parts per square inch, like this. Then bar, torr, different types of unit. So if I consider that the environment pressure is 1 atmosphere, which corresponds to or which equals to 760 millimeter Hg. This is also another unit for the pressure. So this is 760 millimeter Hg or 1 atmosphere, 1 atm. That means this is the environment pressure, which corresponds to 10 to the power 2 torr, I guess. 10 to the power 2. That means 100 torr. So if I consider, or just I don't need to this one, I'm going to give you another number. So 1 atmosphere, this is our environment, and using our system, we could pump out the gas to make the inside pressure 10 to the power minus 10 atmosphere. Can you imagine how low the pressure is? So that is called vacuum pressure around, or sometimes even we can go even lower. That is called ultra high vacuum. That means minimum is the pressure 10 to the power minus 12, and if you can go 10 to the power minus 12. This hot water? Okay. Do you have? No, it's not. Just one only. Okay. If we have the pressure very low, around 10 to the power minus 10 to minus 12 atmosphere, then we can call this pressure as vacuum or ultra vacuum. So, form of energy transmission, that means we are doing the experiment in our system, making the system as vacuum, and then we are giving some laser. In last class, maybe I have mentioned that we are giving this types of laser. This is visible laser, and we can, if we give this laser to a molecule, then this molecule can absorb the light, and it can either excite from ground state to excited state, or it can decompose. If you give high energy, in that case, it can break the bonds. So all the molecule what we are giving energy, it can absorb light or not, depending on what types of energy we are giving or how much the energy gap between the ground state or excited state. That is, so energy propagates by means of electric and magnetic field. Okay. Sorry. Hello. Hello. Hi, sir. আচ্ছা আমি এখন ক্লাসে আছি পরে কথা বলবো সরি ওকে energy propagates by means of electric and magnetic field That means, as already I have mentioned, that this is the kind of wave or magnetic field. So this light or electric field or magnetic field or energy, it's propagate like as electric or magnetic field, that is produced by an accelerating electrically charged particle. That means the here how I am generating the light. Here we have some dry cell, that means battery. So we have some electrically charged particle that is generating this electromagnetic wave. So something like this. For working a laser, we need very high laser electric power. So we are applying certain potential difference so that it's creating some electron. So produced by accelerating electrically charged particle. So by that way, we can generate the electromagnetic wave, or just the magnetic wave, what we said, alternately increase and decrease in intensity. Just as I have shown, if we consider this is the in baseline or just in normal space. So if we consider from here, the intensity is increasing and periodically it is decreasing with time. Again it is increasing. So alternately increasing or and decrease, increase and decrease the intensity, just like any wave. All of you are familiar with these terms, is it? Frequency, then wavelength and amplitude. Oh, I didn't wanted to show that one. I wanted to ask any of you to draw and to show, but already. Okay, as already I have drawn this slide. So just okay. Now you cannot see. Okay. Anyone who can tell about the frequency? What is frequency? Number of waves. Yes, per second. You need to per second or per unit time. Okay. Per second is fine because most of the time we use the time as unit. So number of oscillations or number of complete oscillations per second. That is the frequency. Okay. So any event, we can consider the number of events per second or per unit time is happening. The clock is moving the second, the line or it is moving in 1 minute. That means what would be the frequency for this? Can you count? It is circulating in 1 minute once. The largest. Then 1 minute it is moving one time. Then what is the frequency? 1 frequency. What I have mentioned. Huh? There is no wave? No, that is kind of wave. If you complete oscillation, if you start from 12, let us consider you are at the 12. So it is coming like this way and then coming back way, again it is going back way. Continuously it is moving and moving, moving and moving. So just it is taking 60 seconds for one complete oscillation. Is it? 60 seconds for one complete oscillation. That means what would be the frequency for this? This is one question for class test. Quiz. Sorry? What is the frequency? Definition of frequency? Already have mentioned, is it? Why you cannot calculate? This is the frequency. How many oscillations in 1 second? In 60 seconds, it is giving one complete oscillation. Then, in 1 second, that is the frequency. Is it not? So, in one of my last class, in last Thursday, I have asked to one student. That means, what is the definition of molarity? I had a water bottle, 1 liter. I have shown that this is my 1 liter water bottle. I want to dissolve sodium chloride in that bottle. 1 liter, I want to make 1 liter sodium chloride solution. I have that 1 liter bottle in my hand, and I asked my student to calculate how many grams of sodium chloride I need. Can you calculate? I want to prepare 1 liter of 1 mole solution of sodium chloride. How many grams of sodium chloride you need? First, try to guess what is the definition of molarity. Yeah, that is okay. Then calculate how much sodium chloride I need to prepare 1 liter solution of 1 molar. I want to prepare 1 molar solution. Then how much sodium chloride you need? Do you need to have the molecular weight for sodium chloride? I can give you the yes, 58.5. So that means the molecular weight for sodium chloride NaCl is 58.5. Yes. Then what is your answer? How many grams of sodium chloride I need to prepare 1 liter of solution? What about others? You get confused? This is confusing question, nothing else. Because already you know the definition of molarity. That means molarity means 1 mole. Is it? I want to prepare 1 mole. Then what is the volume I wanted? 1 liter. I wanted to prepare 1 liter. You know the molarity. That means definition of 1 mole. So I want to prepare 1 mole solution of 1 liter. Then how much I need? Just is it? Okay. So that is very simple, and you need to think what is my question. Just by this way. So we could not calculate the frequency for this, is it? From here we are coming here. Okay. So then we have mentioned that the frequency is the number of complete oscillations or complete events in 1 second. Okay. Then what is the wavelength? Yes. Yeah, that is okay. But you always don't need to have the maximum or minimum. You can have 2 identical points. This is our wave. So you can start from here. You can calculate. That is, this is going up. This you can have from here. Even you can have from this this to this. To up or to down, even we can go, we can compare another one. So maybe we can just do 5. So that is the wavelength. Okay. Okay. One gave me the answer from online that the frequency for the oscillation that could be 1/60 seconds you mentioned. Okay, thank you. And you wanted to show the wavelength is represented by a symbol lambda. Okay. That is just like this way. Yeah, coming. Also, just give me your roll number or name that I can give you.
I can write.
Okay, sure.
I can write an email to you.
Oh, sure, that is okay. Okay, then this is the wavelength already mentioned, and we can have another term. What is amplitude? Amplitude. Do you know what is the amplitude? Amplitude. Okay. This is our baseline or the equilibrium. I could say equilibrium position. So distance, maximum distance from the equilibrium position in any direction. That is our amplitude. So this is the wave. So the maximum distance from the equilibrium position in any direction. This is called the amplitude. Okay. And last one, what is this? Okay. All of you know the speed of light. Is it? 3.3. And then you told -8. Is it? It should be. Okay. Then what is the unit? You have mentioned. Okay, I will write down 3. 3.2.9. Okay, what is the unit? 2.99 then? Meter per second square. Okay, you have mentioned 2.99 into 10 to the power 8. Then unit meter per second. Okay, -1 or -2? What? You told per second square. And then you told per second. But what is the unit for velocity? No square. The acceleration is the unit for acceleration is per second square. So unit for velocity is per second. That means velocity. That means total distance divided by time. That means how long distance you are traveling in 1 second. That is the velocity. That means how much distance, or actually velocity is a vector quantity. So it should have some direction. So in how much displacement. Displacement and distance, these are two different quantities. One is vector and one is scalar. So distance. If the distance is scalar or vector? Distance. Yes. Okay. Then what is displacement? It should be vector because it should have certain direction. Okay. So don't get confused. Just we can do mistake, no problem. Just try to think. In class we had calculation, that means regarding how fast one heavier molecule can go. So that we can do mistake, no problem. So that is our amplitude, and the velocity, that means in 1 second how much displacement or maximum, what is the distance it is traveling in 1 second, that is the velocity. So for velocity of light, Do you know how long time it takes to come to the light? Light coming to the earth from sun. Maybe I can give you the number. It takes around, that means from sun to earth, it takes around 98 seconds. No, it should be 8.2 seconds. Not 8.2 seconds. It should be 8.2 minutes. I guess it should be. No, you can search it. It should be 8.2 minutes or 8.18 minutes, like this. The time taken to travel light from sun to the earth. Just you can search. How much time? 8.33 minute or second? Minute. Yes, I told her. I told 8.2. Now, can you calculate what is the distance from sun to earth? You know the time to travel from sun to earth. That means you know the velocity of light. Okay? You know the velocity equal 2.99 into 10 to the power 8 meter per second. And then you have that 8.33 minutes. So it should be 8.33 multiplied by 60 seconds. Is it? Yeah. So the distance just multiplied by 8.33 into 60. That meter. So meter per second, it should be ultimately that much meter. So 149.44 into 10 to the power 8, 9. Only 9. I guess it should be 1. Oh, okay. You have mentioned 149. Okay. So here you have mentioned 9, is it? Okay. Then we can write down 1.49 10 to the power 11. That is in meters. So if you make it kilometer, then we can go 1.49. Kilometer? Yeah. Okay. So I don't know what is the number you have mentioned. Just this is a simple calculation. You know the velocity, you know the time, total time traveling. So you can calculate the distance easily. What is the distance from sun to earth to sun? Okay. And another very information that, do you know the closest star? Closest star, how long time it takes to travel the light from the closest star to that? Except that. Yeah, closest star. It may be around 8.3 light years. Light years. I cannot exactly remember, but it is okay. Another, that means the light years. Light years is not a unit for time. Light years is a unit for distance. Light years. That means what is the light years? Okay, yeah. That means this is the distance, unit for distance. How far from the earth? Something very unexpected. That means light years. Then how it comes? The unit for distance. Can you explain, or can you imagine how it is possible?
You said in high school, I heard the explanation that the light yet it comes like after a long time. So the stars we can see right now, they are not like the light that they start.
Not like this. Just this is a unit for distance. So actually the distance is so far. If we want to express in this types of unit, that is not a very good way to represent. So we are using a very large unit, light years. That means how long distance light will travel in 1 year. That is the light year. How long distance it will travel in 1 year. That means light is traveling how much this meter in 1 second. Then how much it will travel into this much meter into 1 second. So it will move into 365 days multiplied by 24 hours multiplied by 3600 seconds. Like this. So that is so this is our meter. This is a number. How much light will travel in 1 year? And you have mentioned that the closest star, it takes, the distance between the closest star to the Earth is 4.9 light years. That means if you consider that would be 1 light year like this. So 4.9 multiplied by this, that meter is the distance from the Earth to the closest star. 4.9 multiplied by 2.99 is 10 to the power 8 into 265 multiplied by 24 multiplied by 3600. So that meter is the distance to the closest star from the Earth. So just I am using this.
The light we see from the stars we see right now, maybe some stars they are like registered many years ago, because of this light here, we are seeing this registered after so many years. So there is some kind of quantum mechanism.
Yeah, that can be because the lights already created and the star already dead, and it taking quite a long time to come to the Earth. However, if we consider, that means normally a star do not die within very short time, but however there are millions of stars. So some of them are generating very often, and some of them are dying. But it can happen. What you are saying, that can be. But I'm just going to give you the idea about the light years. That means what is the distance between the sun to the Earth to the any star. So we are discussing about the velocity of light. So I am using that term to define the distance also. So higher frequency has a shorter wavelength and higher energy. That is already we have mentioned that for electromagnetic wave, for any in last classes I have mentioned about the sunglass. No? Why we use sunglass? That means to protect our eye from sun. That means if sunlight comes to our eye, what will happen? Our eye can be damaged because we are protecting the UV light. UV light is very high energized light. The frequency of the UV light is very high. If I say that the frequency of UV light, that means if I write down the number 266 nanometer, That is 266 nanometer. That is UV light. And that in terms of energy, if we write down 4.66 electron volt, and if you go for frequency, that would be 4.66 multiplied by 8065.5 per centimeter, like this. So 4.66, that means you can consider 5. 5 into 8,000, around 40,000. That means the 40,000 wave number, this is very high frequency and it's a high energy. So if you have that types of light or that types of electromagnetic wave in your eye, that can damage your iris or eye completely. Therefore, to prevent that sunlight, that will protect. That means the sunlight, we are using a sunglass. Just as you can see, this light cannot penetrate through the hand. That means if we use just a small piece of plastic paper, it can penetrate through the plastic paper. So it cannot help because it will absorb most of the light. You can, okay, no problem. Just if we have some transparent, that means it will transmit all the lights. But for sunglass, we have the glass material in such a way that it can absorb. It can absorb the UV light and it can penetrate the visible light. Why visible light? Why it will penetrate the visible light? Yes. If you do not have the visible light, then you cannot see anything. So to see, we need to have the visible light to come into our eyes so that if we can see something. But for UV, we don't need to see that one UV, and it is very high energized. But this glass can protect the UV? I don't think so. Normally what we use, sunglass, especially for sunglass. These glasses are not sunglass.
But they change color, like they change.
Okay. Yes, that is another type. You can say polarized sunglass. That is quite expensive. More normally for polarized sunglass, it's around $200 or $250 per one pair. That can be even more expensive. How it works? That is when you drive with very hot sun. Sorry, desert. Yeah, that can be. And in that time, during the driving, you can have some dizziness because the light is falling on the hood of the car and it is reflecting. So, and it is reflecting, it is coming to your eye. In that case, you can see dark and you can feel dizzy. But if you have some polarized sunglass, in that case, I have some slide. Maybe if you want to see, I can show you. Okay, just a second. Okay, that will be fine. Here you can see this sunglass. You can see that one little darker, but you can visualize the edge of the mountain or hill also. But through this region, you cannot see clearly. It is looking little dark here. However, you can understand the shape much clearly compared to this region, because here from the wave, that means water, the wave is coming in different scattered way. But this types of polarized sunglass, it allows the light to come only in single direction. So it can pass only this vertical line. So if there is any horizontal line or a scattered way, the light will not penetrate through this glass. So when someone driving the car in the desert, so if the scattered light comes to the eye, then the driver will feel dizzy. And also sometimes if it is little bit dark, that means sometimes due to dust, you can have the dark side. So if you have the reflection, that will distract your view. So that if you have these types of sunglasses, then only one direction, that means you need to see very far away from the from your car while you are driving. So you need to see far away. Very close you don't need to see. But if the scattered light which is disturbing to from the hood, that time your visualization can be distracted. Therefore, just single directed light, if you can see, that can help you, and you can see very far away using this. So for this one, compared to this region, we can see much clear view, though it is little bit dark. Why dark? No, some of the light is not coming to our eye, because some of the light is blocked. Because I have mentioned that it will come only one directed light, but scattered light, whatever it is in going like this way or any other angle, so that will not come to our eye, so will little bit darker. However, the image would be clear. Okay. Electromagnetic spectrum, what already mentioned, that this we can see as we go from left to right. These are the wavelength. If you consider from here to here, the wavelength is just only this much, very small. If you consider from this here to here, that means the wavelength is increasing. So you can go on another far more. So wavelength is increasing. So wavelength is increasing, but energy is decreasing, because we know that wavelength and energy are inversely proportional. Okay. The continuum of radiant energy, all the waves in the spectrum travel at the same speed. So what about the electromagnetic spectrum? We can have any waves, all the waves here, from the gamma rays to X-ray, whatever, UV, or this is gamma, X-ray, ultraviolet, infrared, radio wave, microwave. radar wave, whatever, all of them have more or less same energy, same speed. They differ in frequency and wavelength. So they have the same speed, but they have different frequency because their wavelength is changing. So as the wavelength is changing, it is having that the energy is changing. So in this region, this gamma ray, X-ray has very high energy. So this gamma ray or X-ray, it can penetrate through our body, so that we can take the image of any broken bone, and this is very high energy, so that we should not have the X-ray very often. It can damage our case.
What do MRIs use? Like what kind of wave?
MRI.
Yes.
What are the waves it uses? Exactly, I do not have the information yet. I do not know. In next class, I will try to give you answer. Okay, so this X-ray, ultraviolet ray, we can ionize any molecule. We can remove one electron from a molecule by using this energy, this mass energy. But if you give this energy, that is very high energy, this energy, it is possible to break the molecule, to decompose most of the molecules. And so that if we take X-ray, some of our cells can damage. So we should not take the X-ray very often. And these are very high wavelength energy, that is very low energy. This one, no, that should not be not so harmful, because you have for 24 hours you are carrying the mobile phone. Is it?
Yes.
24 hours. So that is in this region. That is not so harmful.
Why do they say that the radio wave becomes like really high when your battery runs down to like?
Okay, that is the property. That is the property of radiation. That means what types of chemicals are used inside our phone in the battery, lithium-ion battery. Normally we say. So that is the property. That means when the charge is quite low, that time it radiates the frequency that should be little higher energy. Normally, when it has full of charge, in that time you will have the little lower energy region, and if you have very low amount of charge, in that case it will radiate in this region. That means relatively still, if you have 10% or 5% charge, you do not die. Is it? You do not die, but scientists or those who are aware, they tell that you should not use like this way. So I am telling that normally you may consider that the radiation from the mobile phone is coming out in this region, but if you have the charge little bit less than 15% like this, you can have the radiation around this region. Still, it is not very bad for our health, but if you continuously use, so normally even we are not interested to have any light unless you want to have the sun bath. You do not want to go to the sun unnecessarily. So even someone go to the sun bath, they block the eyes with some handkerchief or something like this. So we do not want to have the energy. So even those who are going to sun just for a short time, continuously, no radiation. You should not use the radiation, continuous radiation anytime. Even another way, not only while you have the less charge, while you are charging your phone, you should not talk to someone, because even that time the radiation increases even more, because that is happening the phone is charging and discharging same time. Because the phone is charging from the electricity that time, and I have found some videos that while the phone is charging, that time if you hold the phone, the electricity passes through your whole body. Just I have seen one kid is holding the phone like this way, not talking just right, and from other hand, the another person is detecting the electricity through his hand. So one hand his phone, another hand has the detector. That means how much electricity is passing through his body. So normally, if you try to talk to phone while you are charging, that time the radiation and even electricity is passing through your body. So try to avoid talking during charge.
How strict near your devices?
Yeah, that is also try to avoid as much as possible. Try to avoid the radiation as much as possible.
It's not getting charged before, and you were talking like for a long time. You turn on like Bluetooth one. It's suggested in some articles or something.
Yeah.
And if you are talking for a while, like long time, you turn on that Bluetooth one. This is
Bluetooth.
one.
That is, I have to seen some of the researches like this way. They are mentioning like that way that if you want to talk for a long time, just better to use headphone, not the.
And recently, just like on your website, things like it brings content to your right ear, so even when you enter your column, you use it on your left ear.
Yeah, and that is another. So there are many things regarding we can discuss, but as we are a little bit out of our syllabus, so we are not going to discuss too many things outside our syllabus. So the differ in frequency and wavelength already we have mentioned that whatever the light we are having. Okay, so as we go from left to right, the speed of the light do not change, just changes the frequency and the energy or wavelength. Okay, then you are familiar with this one, interference of light, interference or resonance. Okay, that means if you have two lights or two waves of same phase, that means here you can see this light wave and this light wave has exactly similar pattern, just increasing, decreasing. That means at the same phase. So if two light waves of same phase come close together and overlap, in that case, the resultant intensity of the light at this point, this is the top, so that will sum up to give a high intense light. And if they are in opposite phase, that you will get something like this. That means if it is opposite side, that means if you consider like this way, +5 -5, it gives 0. +5 +5, 10. -5 -5 -3. So this is -5 -5 -5 -5 +5 +5 like this. So when they are in same phase, you will have something like this. 10. This is -10. This is what we have written the 10. So you are getting the high intense. This is more intense, and this is less intense. That means minimum. So if we have these types of waves, two waves of same phase and same wavelength or same nature, in that case, these two waves will give the resultant with very high intensity that is known as interference of light, and I would say this is constructive interference. Constructive interference, and if we say that two light waves have different phase or opposite phase, then one each other cancel out, and then yes, we get just a straight line or very less intense signal. If they are not exactly same phase, not exactly the opposite phase, if it is little bit displaces, maybe it is started from here, and so it can have, in that case, it can have very low intensity, something like this.
Totally imaginary, or we have real life examples also for these concepts.
Yeah, it should be just exactly if you have the same two waves and with same phase, exactly same. In that case, you can have the constructive and destructive. That means if you have the same wave with opposite phase, only this, that would be the destructive. That means it will give you a straight line with the zero intensity. Quantum theory. Okay. Energy, like matter, is discontinuous. Okay. Discontinuous, that means, maybe better I go in the next slide so that we can make you a little bit idea more clearer. Okay. Here, this is an atom. We are considering the hydrogen atom. So, this is our first shell, second shell, third shell, fourth shell. Actually, in hydrogen, we have only 2 electrons. So, all of you know that these 2 electrons stay in the first shell. Yeah. But if you give lot of energy, in that case, these 2 electrons can jump up. It can jump up from this inner shell to somewhere else, depending on how much energy you are providing, how much energy you are applying. In that case, if you have given lot of energy, that means this is our first shell. If you give lot of energy, that means 94 nanometer, corresponding to 94 nanometer. If you calculate the energy for this light, it would be around 13 or 14 electron volt. Just you can calculate using 1239.85 divided by 94. That will give you just like this way, 1239.85 divided by 94. So you will get around, maybe you can get the number 14 something, 14 electron volt maybe. You get the number 1239.85. This is a constant number. So when you want to calculate the energy of any light, 13.19. Okay, 13.19, that is electron volt. So if you want to calculate the energy of any light, that is the formula. That means this is our lambda. Is it? That will give you, this is just normally formula. In previous slide we had the, yeah, EF equal NH nu by this way, or yeah, just you can write down energy of any wavelength or any light. You can calculate by 1239.85 divided by lambda in nanometer. Okay. Lambda, energy of light, any wavelength, energy of any wavelength, you can calculate by using this formula. That will give you in electron volt. So that is a constant number. This is a constant number, and then divide by the lambda. Then you will get an electron volt. So what we are telling here, that if you give some energy, that means if you give 13.19 electron volt energy to this hydrogen atom, electron will jump from this first shell to the second, third, fourth, fifth, sixth shell. So just if you give that much energy, that will jump up the electron from first shell to sixth shell. So that is very high energy. Now, if you take out the energy, that means you are not applying any more energy. In that case, that electron will come back to the first shell. Is it? It should be, because just we have excited the electron to somewhere else, but when we release the energy, it should come back to the original position. So in that case, if you have several other middle steps, because we have mentioned that all the energy levels are discrete, not any continuous. So if it reduces or if it releases some amount of energy, we have given that much energy, that means 13.19 electron volt. Let us consider it has released 10 electron volt. Then, so it should not come back to the first one, is it? Still, this electron has some energy. We have mentioned we have 13.19, but it released 10 electron volt. So still the molecule, the atom or electron has energy 3.19 electron volt inside the electron. So do you think it should come back to the first shell?
No.
Then where it should come back? Somewhere in between, that means either this one or this one, depending on the energy. So if the electron come back to the first shell, that will exactly emit whatever the energy it has absorbed. So if it do not come back to the first shell, it can come back to this one or this one or this one or this one. Sorry. So from sixth shell, it can come back to this, or anyone. So if it releases some energy and come back to this second shell, in that case, we will get some radiation. That means it is releasing some energy. How? By some radiation. That means it will emit some light. So we will get some radiation, and that will correspond to the Balmer series. If the energy, that means the electron we have excited in the sixth shell, and it is radiating some energy to come back to the second shell. So if it come back to this shell, so how much energy it is released? Corresponding to that, we will get some radiation, and that will be observed like a Balmer series. This is the Balmer series, BALMER Balmer series, and if it radiates or if it releases a little bit less and come back to the third shell, then we can call it Pastel series. So that is the way how we can observe different types of radiation or different types of electromagnetic waves from the excited atom. So all these energy levels are discrete. That is the meaning. If you want to transfer one electron from this shell to this, you need to have certain amount of energy. Just how much energy? If you have more energy than this, then it cannot come back to the in middle somewhere. Just if this electron has exactly exact amount, how much is the gap? Maybe 2 electron volt. Just let us consider. If the energy gap between first shell to second shell is only 2 electron volt, then if you provide some energy corresponding to 2 electron volt, that electron from the first shell can jump to the second shell. If you have more than that energy, maybe 5 electron volt, that can be the difference between this one to this one. So in that case, that will not come to this one, it will directly come to the first shell. So depending on how much energy we are applying to the atom will have the where it will go, or even we have already mentioned, when the atom releases when the electron releases the energy, in that time it cannot radiate any wavelength, any radiation it cannot, because it cannot radiate some energy which can come from the end, that is 6 shell to in between 5 and 6. It cannot. Or even it cannot come back in between 4 and 5. It needs to come back, it needs to release a specific amount of energy so that it can come back to the 5th, 4th, 3rd, 2nd or 1st, like this. So only that much energy can be gained or lost to transfer from one orbit to another orbit, or one shell to another shell. Okay. Energy discrete set of specific values, already have mentioned that all of them has certain amount of value. So maybe we can consider this is 1.2 electron, this is 4.5 electron volt or 2.5 electron volt. In between there is nothing. These are empty space. Electron cannot exist in this region. So if you have some electron, and if the electron has certain amount of energy that can jump from here to here, then you can get, or only this discrete amount or a specific amount of energy can be helpful or useful to transfer electron from one orbit to another. Then higher orbit excited state. Okay, this is our ground state normally for hydrogen atom. So if you have the electron from first orbit to second orbit, normally it should not be, because what we said in the hydrogen, in the ground state, it should be in the first electron shell. So if any electron in the second shell, that should be excited state, or even any higher others, that is also excited state. Emission of photon of same energy back to the ground state. Already I have mentioned that if we give this 13.19 electron volt, that will go back, that will take the electron to the 6th shell, and if it can release exactly 13.19 electron volt, that will come back to the first shell again. So emission of photon of same energy, that means that will correspond to 94 nanometer. If it can radiate 94 nanometer, then it can come back to the original state. But actually this is quite difficult. Most of the time, how much energy it is absorbing, it cannot release same energy at the same time. So it can radiate step by step. So it comes to this step first, then here, releases step by step. So we can absorb different types of band spectrum. Can you mark me present? Okay, Subha. Okay. Tired? Yeah, I think we can end up. Yeah. Okay. Thank you very much. Sure, I'll print it.